Hello YouTube, this is a quick video I'm putting together over the concept of unit vectors and what they are and how you find them. So let's go and start with what they are. We say, first of all, in many instances it's really convenient to use vectors that have same directions as something else, but that have a unit of 1. So when you hear a unit vector or length of 1, we say it is a vector with a magnitude of 1. It's kind of like the unit circle. And so if we want a vector of magnitude 1, it all kind of lies in one key fact. Given a vector, we say, like, I don't know, let's call this vector v. This vector v has some length, and we usually refer to the length of a vector as its magnitude, and we write that this way. So we say the length of v is given as this value, like right here. Fact is, like, if you've ever operated with vectors before, especially with scalar multiplication, if somebody's asked you to find 2v, what you know is you're actually going to be heading in the same direction. It's just that you'll be, say, twice as long as your original vector. Or if you wanted to do like negative 3v, what would that look like? Well, it'd be like 3v's going exactly in the opposite direction, but it'd be 3 times as long as v, and it'd be going the other direction. Our job here is to take any vector and have it still go in the same direction, but have a magnitude of 1. So there's like a really easy way to do this. Let's say I gave us a vector, and its vector is, it says v, and I say the magnitude of v is equal to 8. That is, this vector up here is 8 units in length. It is a magnitude of 8. There is one way we could keep this going in the same direction and give it a length of 1. What we could do is we like take it times a half, and now it have a length of 4, and take that times a half, now it has a length of 2, and take that times a half, now it has a length of 1. And so you'd have this vector now, if I took the original one times a half times a half times a half, it'd have a length of 1. In other words, a half times a half times a half times 8 would have been the same thing as 1/8 times its original length, which is 8, and we get 1. In other words, here's what I want to bring out. Basically, if any vector, when you multiply it by a scalar, it does go in the same direction. It just scales it up or down. The question then becomes, what could I take a vector times to make its length 1? And very simply put, what we could do is we could take the original length of the vector times its reciprocal. So, put it in a nutshell, we say a unit vector u. We say this is this vector u. In order to find this, we take an original vector v, and we just divide it by its own length. So in other words, if vector v had a length of 10, we'll divide it by 10, and that'll bring it down to a length of 1. Another way to write the same quantity would just be this. It'd be, multiply the vector v times the reciprocal of its own length. In other words, if it had a length of 8, we'll take it times 1/8. If it had a length of pi, we'll take it times 1 pi. If it had a length of 20, we'll take it times 1/20, and that'll shrink it down to a length of 1, okay? So real quick, before we actually do this, we say the vector u, I just want to be clear on this one, it is a scalar multiple of v. In other words, if I give you some original vector v, here's our v, and I say, now I want you to write me a vector going in the same direction with the magnitude of 1, like this is our vector u, and we say the magnitude of u equals 1 and be a unit vector. What I want you to know is this: we could get u just by taking v times a scalar, and that scalar happens to be the reciprocal of its own magnitude, okay? So we're going to find a unit vector u in the direction of this guy right here, v, and then we're going to verify that it has a magnitude of 1. So let's go ahead and start with this. I've already been given this in component form. Okay, remember component form, it just says, well, we understand that this vector starts at 0, 0. This is where it terminates. So we'd go 1, 2, 3, 4, 5, 6, 7 to the right, and then down 3. We'd say this is our vector right here. Now, I know this vector is actually in component form, but it is not a unit vector. And it'd be really easy to check to see if this is a unit vector. We could just do some Pythagoras here. And we know that this is 7 and this is negative 3. We'd say the magnitude of the original vector. Let's go ahead and start with the magnitude of the original vector. Remember, it's just the square root of its components squared. So 7 squared plus negative 3 squared, the square root of this. So we get the square root of 49 plus 9 is the square root of 58. In other words, the length of the original vector is this length right here. What we want to do is this. If we want a unit vector, we will just find this right here, which in other words just says this. If this is my original magnitude, we will say my unit vector u that's going in the same direction would be the original vector v times 1 over its magnitude, which is radical 58. So if it originally had a magnitude of radical 58, then we'll just divide it by its own magnitude and I have a length of 1. So in order to finish this, here's what it looks like. We say 1 over radical 58. We're taking this times the vector v, and the vector v had components positive 7, negative 3. So we know we can actually distribute this. Now, this is the unit vector right here, but you're going to see a lot of the times it'll be written this way. We say 7 root 58 over 58 is our x component. We have negative 3 root 58 over 58 is our y component. So this is our unit vector u. In order to find it, all we did was we took the original vector times the reciprocal of its magnitude. That's all we have to do. Okay, so when I did want to verify that this, actually, I suppose, has a unit length, we could say, all right, well, that'd be the square root of, oh, this will be fun, or 58. Actually, let's just do it this way. If we had 7 over radical 58, that's squared, I'm getting this from right here, plus negative 3 over radical 58, that's squared. Let's see if we get a length of 1 here. So we'd get square root of, on the inside here, 49 58ths plus 9 58ths, which is the square root of 58 58ths. We do get a magnitude of 1 on this vector right here. So that's what we wanted to do. So that's what a unit vector is. It's the original vector divided by its own magnitude, or multiplied by the reciprocal of its own magnitude.